Hey everyone, welcome to CafeQED. My name is Peter, and today let's talk about the quotient rule for taking derivatives. So, as the name implies, the quotient rule is meant for taking derivatives of functions that are themselves quotients. So, for example, if we have a function that can be represented as f of x over g of x, where f is our numerator and g is our denominator, then the quotient rule says that the derivative with respect to x of f of x over g of x will be equal to g of x times f prime of x minus f of x times g prime of x all over g of x squared. So the first thing I notice about the quotient rule is that there are a lot more terms to memorize than the product rule. And secondly, because of the minus sign in a numerator, we need to memorize the terms in the order in which it is written. Otherwise, we wouldn't have the correct quotient rule. But fortunately, I do have a nice way to memorize the quotient rule. And I can't take any credit for this. This is something I actually learned from my high school math teacher. So, Mr. Brown, if you happen to be watching this video, thank you very much for teaching all of this insanely helpful way of memorizing the quotient rule, because I still use this to this day to take derivatives of quotients. Okay, so now here it is. It says low d high minus high d low over the square of what's below. Sounds kind of nice, right? Let's say it again, but a little bit faster this time. Low d high minus high d low over the square of what's below. All right, so now let's see how this actually helps us memorize the quotient rule. So first, low stands for denominator, high stands for numerator, and d stands for derivative. Okay, so now if we look back at the quotient rule that I wrote above, we'll see that low d high translates very nicely to g of x times f prime of x, where this is denominator times the derivative of the numerator. Then minus high d low translates nicely to f of x times g prime of x, or the numerator times the derivative of the denominator. And then finally, over the square of what's below. So we divide by g of x squared, or divide by the denominator squared. All right, so that's my nice little trick for memorizing the quotient rule. If it helps you memorize it, awesome. If you want to memorize the quotient rule your own way, that's also fine as well. But just in case you need an extra tip, that's what I've been using all this time ever since taking calculus, many, many years ago. Okay, so now that we've talked through the quotient rule, let's see in action on a few example problems. So for our first example problem, let's look at the function f of x is equal to x to the fourth plus x to the negative 2 over x plus 2. And we want to find the derivative of f. So the first thing I notice about this function is that it's a quotient, right? So this means that we should be using the quotient rule for taking a derivative. Before we actually start differentiating this function, let's quickly review what the quotient rule says, both the mathematical expression way and also the rhyme that I introduced earlier in this video. The formula way says the derivative of f over g is equal to g times f prime minus f times g prime all over g squared. And in this notation here, I'm purposely using a shorthand notation, omitting the fact that each of my terms are a function of x just to, shorten the notation for us. But in reality, my f and g are actually functions of x, or functions of some other independent variable. Okay, so now the rhyme version of the quotient rule says low d high minus high d low over the square of what's below. Okay, so now let's go ahead and take the derivative. F prime of x is equal to low, which would be x plus 2, d high, which is the derivative of the top, so the derivative of x to the fourth plus x to the negative 2, minus high, which is x to the fourth plus x to the negative 2, d low, which is the derivative of the denominator, so derivative of x plus 2, over the square of what's below. So we divide by x plus 2 squared. Okay, so now we need to figure out the derivatives of these two terms in the numerator, the derivative of x to the fourth plus x to the negative 2, and the derivative of x plus 2. But both of these can be evaluated using the sum rule, which says that we can distribute a derivative into a sum, and then followed by power rules. Okay, so let's go ahead and do that. We get x plus 2 times the derivative of x to the fourth is 4x cubed, and then plus the derivative of x to the negative 2 will be negative 2 times x to the negative 3. Then minus x to the fourth plus x to the negative 2, and then the derivative of x is 1, and then the derivative of 2 is 0. And then all of this is still over x plus 2 squared. Okay, so at this point, we've evaluated all the derivatives that we need to figure out our derivative for f. So technically speaking, we could leave our answer in this form, but I'm going to simplify the answer into a more compact form because this is something that you guys might have to do on homework and probably on exams as well. So it's always good practice to work these problems out. But I don't want to bore you guys, so I'm just going to fast forward through the rest of my work and then we'll meet up again once I get to the answer. All right, so here we go. This is what I got for the derivative of f. And again, for this problem, it was just a straightforward application of the quotient rule and then basically just working out the algebra until we get to a compact form for our solution. All right, let's take a look at another example problem. For our second problem, we have the function g of u, which is equal to u squared times the quantity u plus u to the negative 1 all over 2u plus 1, and we want to find a derivative of g. So again, I think we all recognize that the function is another quotient, which means we can use the quotient rule. But before we go ahead and take the derivative, I do want to point out that there are two different ways, so two different approaches for this problem. The first way is recognizing that our function g of u can be simplified if we distribute out the numerators. So we would get u cubed plus u all over 2u plus 1. And in this form, this is just a regular quotient rule, just like our previous problem, right? So we would just go through the same steps and we would also arrive at the answer. The second approach is just to differentiate g in exactly the form that I handed it to us, right? And you might think that, well, duh, we can just differentiate directly. But the reason why I would consider these two different approaches is because the first approach, this one, if we were to simplify it, is actually a lot easier, simply because it's just a quotient rule. If we were to differentiate directly using our second approach, notice that the numerator is a product, which means that whenever we need to take a derivative of the high or take a derivative of the numerator, we need to apply the product rule, which means that we just have to add an extra, maybe layer of complexity into this problem. So for the purpose of demonstrating this to you guys, I'm actually going to choose the second approach, simply because I think for most people first learning the quotient rule, it might not occur to us that we can simplify our functions before going into these rules. We might just end up throwing the first rule we think of at the problem. So in this case, when we look at this problem, we see quotient, so we automatically think, let's apply the quotient rule. Okay, so let's go ahead and try it this way. All right, so we get that the derivative of g is equal to low d high, which is the derivative of the numerator. And I'm not going to evaluate the derivative because I just want to write everything out first. Minus high d low, that will be the derivative of the denominator, over the square of what's below. So divided by the denominator squared. All right, so looking at our work so far, we see that there are two derivatives that we need to evaluate. The first one is going to be a product rule, and then the second one is going to be a power rule. So let's go ahead and evaluate those. So we get 2u plus 1 times, now using the product rule, we get this is going to be the derivative of the first, which will be 2u times the second, plus the first, which is u squared, times the derivative of the second. So now this will be 1 plus negative 1 times u to the negative 2. Now for the second term, we get u squared times u plus u to the negative 1, and then the derivative of 2u plus 1, well, that's just 2. And then this is all over 2u plus 1 squared. All right, so from here on out, again, just like the previous problem, it's just going to be a bunch of algebra. So I'm going to fast forward through all of my work, but I'm still going to show it just in case you guys want to check your work against mine. this is what I get for the derivative. Okay, so let's quickly recap on everything that happened for this problem. So first of all, we recognize that this function is a quotient, which means you can apply the quotient rule, but I did mention that there are two different approaches to take. The first one was to simplify out the function by distributing the numerator out, so then we just get a simple bare bones quotient rule because it's just one term over another term. The second way was to differentiate directly, which is the method that I chose to demonstrate. And the reason why I chose to do it this way is because of the product that shows up in the numerator. And because of that product, we had to eventually evaluate a product rule inside our quotient rule. But even though it was a little bit messy and it took us a few more steps to get through it because of the extra algebra, we could still get to the answer, right? And this is why I want to demonstrate it this way. Even if we chose the harder of the two paths, at least for this problem, we could still work it out just by following all the rules that we've seen so far. And with that said, I hope that everyone was able to follow along. Alright, so that's all I have for today. If you have any questions, leave a comment below. If you enjoyed this video or found this video helpful, give it a thumbs up. And if you'd like to learn more math with me at CafeQED, hit the subscribe button. And I'll see you all next time.